Hi everyone, and welcome back to my channel. Now in my last video I promised that in this video I would show you my process for carving a fretboard for the base that's been the subject of this video series. I gave you a first look at the finished fretboard in the last video, but here it is again. As you can see, I've also drilled the holes for the tuners and installed them temporarily, just so I can see how they look and also to see how much the neck weighs. I'm happy to report that the neck weighs 3.18 pounds with all of the components installed, meaning the truss rod, the carbon fiber reinforcement rods, and the tuners. I also went back and reweighed the body, which weighs about 3.28 pounds. So altogether, I'm looking at a base that should clock in at around 8 pounds total once the remaining parts and pieces are added, like the pickup and the bridge, the electronics, the strings, and so on. I've mentioned this before, but this is one of my so-called quiet goals for this build. The standard off-the-shelf base typically weighs between 10 or 12 pounds, give or take, so I set myself a challenge with this base to reduce the overall weight, primarily by making the body thinner than a standard base, but also by using lighter wood for the body core and doing other things like carving an extra large control cavity. At the moment, this base is on schedule to be about 20% lighter than your standard base, which is great, but I'm getting a little ahead of myself here, so let's return to the subject at hand, the fretboard. So with this fretboard, the first thing I wanted to try was to create a fretboard that matches the neck shaft. Basically, I wanted to make it out of the same piece of wood, including the laminated part like the stringers here, as opposed to carving the neck shaft out of one piece of wood like maple and then carving a fretboard out of a different piece of wood like ebony or rosewood. So that's the first part of the experiment. The second part involves when you apply your finish to the fretboard. Typically, applying a finish is the last thing you do after carving the slots for the frets, installing the frets, beveling and crowning the frets, rounding off the ends, yada yada. For reasons I'll explain later, I chose to apply the fretboard finish at an earlier stage, and it still remains to be seen whether this strategy will work. In any case, let's dive into the process, and I'll be back as usual on the flip side with some final thoughts. One last administrative thing though. In the last video, I said I'd be showing the process of gluing the fretboard to the neck shaft, but it turns out that adding that part would exceed my YouTube limit for this video. So I'm going to incorporate that part of the process and maybe also the fret install in a future episode. Okay, so just to refresh your memory, I'm taking you back to an earlier video where I put the neck blank on my bandsaw and cut out the slice of lumber that would become my fretboard blank. This scene is actually from when I was carving one of the earlier necks for this build, which I showed you in previous videos. Now that neck turned out to be a difficult carve and I was forced to set it aside for the time being, but the fretboard blank had this really nice modeled figure to it, so I decided to use it on the final neck. Once I had planed the fretboard blank to its final thickness, the next step was to mount to my CNC machine and perform the first carving operation, which is to cut out the pockets for the position markers. To do that, I used a small 16th inch bit, or end mill as they call them. The reason for that is because I want a very sharp and precise pocket for installing the position markers themselves, which actually were left over from the first fretboard I carved for this project. So to install the markers, I just grabbed a bottle of medium CA glue, which is basically a generic name for crazy glue, and then I flooded each pocket with glue and inserted the marker by hand, giving it a little tap with the hammer to ensure that the marker is seated flush with the bottom of the pocket. That's important because with these offset position markers, the marker will intersect with the perimeter of the fretboard once it's been cut, which means you'll be able to see them from the side. That's actually the whole point of the design. I want the position markers on the upper side of the fretboard to function as side markers as well, which saves me the extra trouble of installing separate side dots like you see on most instruments. With the markers installed, the next step is to perform the radius carve, which I'll do using a 1/4 inch ball nose bit. Now over the years, I've kind of been developing a preference for large radius fretboards. In particular, I used to have this Chinese-made Warwick base that I gave to my nephew, and the fretboard on that base is practically flat, which I think is part of Warwick's design philosophy. In any case, that fretboard, in combination with its super jumbo frets, is really comfortable and easy to play, especially if you play a lot of chords like I do. There's something about a standard fretboard radius, like say 16 inches, that forces your hand and fingers into certain positions that don't always lend themselves to certain techniques or playing styles. So in this case, I've gone with a much larger radius, more like 24 inches, which results in a nearly flat fretboard. Now that the radius carve is finished, it's time to carve the little pocket or shelf in the portion of the fretboard at the heel of the neck. This is one of those two-part operations involving a rough carve followed by a finish pass. For both, I'll be using an 1/8 inch bit and starting from the exact same machine coordinates. Now, to be honest, this little shelf is mainly decorative. It's meant to resemble the fretboard on the Ibanez SR6 neck, and I like it as a design element. It adds a bit of variety and depth to what otherwise is a kind of uniform surface. So as with other carves I've shown you, this one started with the rough pass and ends with the finishing pass, which you're seeing now. As always, the goal of the finishing pass is to get the workpiece to its final dimensions and produce a smooth finish, which cuts down on sanding and other handwork. Okay, so here's where things get interesting. I mentioned at the outset that the second experimental aspect of this fretboard has to do with when I chose to apply the finish, in this case 2-part epoxy. Like I said, the standard practice is basically to save the finish until last. That is, after carving the fret slots, gluing the fretboard to the next shaft, and installing the frets and doing all the associated fretwork. One of the issues I've had with other fretboards involves using CA glue to secure the frets in place as you're installing them. I learned pretty quickly that CA glue has very low viscosity, which means that it wicks through wood grain quite easily, even with dense woods like maple or ebony. This can sometimes result in stains or spots of discoloration that are difficult to remove. And the difficulty of removing these spots is compounded by the fact that now the frets have been installed. So you end up having to work around the frets in very tight spaces, which is challenging and really tedious. So by applying the finish beforehand and using a gas match to pop any resulting air bubbles, I'm hoping to avoid all these issues. Now that I've applied the epoxy to the fretboard and allowed it to cure for a few days, I'm ready to begin the all-important fret slot carve, this time using a bit as thin as a needle, about 0.6 millimeters in diameter. I've mentioned before that this is one of those areas where a CNC machine absolutely excels in terms of accuracy and precision. The standard way to cut fret slots is by hand, typically using some kind of elaborate jig to hold the fretboard in place and produce the correct spacing between frets. It's almost impossible to overstate how important the spacing between frets is on a bass or a guitar. The distances have to be accurate within hundredths of an inch. If not, the instrument's intonation will be out of whack. It'll literally be out of tune with itself from one fret to the next. The big advantage with CNC and with computer modeling is that the machine will reproduce the model with an accuracy down to 1/1000th of an inch. So as long as you've created an accurate model of the spacing between fret slots, the machine will carve it. With the fret slots all carved, we're now ready for the final operation, which is to cut out the perimeter shape of the fretboard. This is a fairly straightforward operation with not much potential for error in terms of running the machine, but it does need to be accurate. The final perimeter, for example, needs to match the perimeter of the top of the neck shaft. At most, it can be slightly over because I'll be doing some hand finishing work after I've glued the fretboard to the shaft. But if it's under, I would need to scrap the fretboard and start over. In this case, the fretboard ended up exceeding the perimeter of the neck shaft by a very slight margin, probably because I'd already spent quite a bit of time sanding the neck shaft. Now that's totally fine because part of the hand finishing work will involve tapering the bottom edge of the fretboard slightly to blend it in with the curve of the neck shaft itself. All right, so that's it. All of the carving operations are finished, so now it's time to unscrew the piece from the CNC table and liberate the fretboard from the rest of the blank. But first, I'll have a quick look to make sure there aren't any dings or gouges or other flaws. I'll also check to make sure the piece hasn't warped or otherwise changed shape as a result of the carve, which can happen sometimes. To liberate the fretboard from the rest of the blank, I'll use my trusty multi-tool to cut through the 4 tabs holding the 2 pieces together. Once that's finished, I'll eyeball the fretboard again just to see if there's anything I need to note for later, like whether the finish is uniform enough or requires additional level sanding, or whether the sides of the fretboard have tool marks that are going to require a lot of finishing work. In this case, the answer was no. The sides were surprisingly smooth and even, right off the bench. Okay, so once again, there you have it. My process for carving a fretboard on my CNC machine. Now there's still plenty of work to do. As I mentioned at the outset, quite a few steps have occurred between the time of this video and what you see here, which is a neck that's farther along in the process. Specifically, the steps between then and now, which I'll show you in my next video, involved a lot of handwork in preparation for gluing the fretboard to the neck shaft. I had to install the truss rod and the carbon fiber reinforcement rods, for example, which meant chiseling out some excess wood from the truss rod slot and sanding the top edges of the carbon fiber rods, which ended up sitting slightly proud of the surface of the neck after I glued them in. I also decided partway through that the process I've been using to clamp the fretboard to the neck shaft is not ideal. So I created a clamping jig along the lines of a jig that Chris from Highline Guitars uses on his YouTube channel. Anyhow, that's all for the next video. But as for final comments, I'll repeat that I'm mostly happy with how this neck is turning out, but there's still a very long way to go. I have to install the frets and do all the associated fret work. I'll then need to do any finish sanding in preparation for applying finish to the neck shaft and the sides of the fretboard. At this stage, I'm leaning in the direction of Crystalac as my finish, mainly because epoxy, like I used on the fretboard, would darken the color of the wood more. In any case, that's all for a future video. For now, all that remains is for me to thank you for watching this one. So until next time, cheers.